Okay, so this will be just a quick rundown of what you've seen over the last couple of days and kind of putting it all together. So if we're looking at a question like the one given, f at x equals, and we have all the different values plugged into our equation. Be careful to note that there are, oh look at that, I messed it up. There are two sets of brackets here, with the square bracket closing here. If by chance you don't have that inside open, it has to be that set up that way. So find amplitude, period, phase shift, and vertical shift. So doing them in this order, amplitude is simply the value in front. So pretty straightforward stuff. Amplitude is 3. Again, amplitude is, for those of you who sort of haven't quite got the terminology down just yet, amplitude is in our original sine curve, size of the crests and troughs, if you will. So the amplitude is 3. The 4 here tells us the number of full waves we have in the 360 degree range. In our original sine curve, this would be 360 over here. So we'd have one full cycle. This time we have 4. So to actually do this, we had a little calculation we can do. Just clear this out. It's 360 degrees, and not really a very surprising one, divided into 4 equal sections. Each period is 90 degrees. So one full set of waves, one full cycle occurs over 90 degrees. The other two values, obviously, the phase shift is negative 160 here. Determines our phase shift. And we do have to be careful. Phase shift is the amount we'll be moving, but as it was with quadratics in the past, what we're really looking at is what value of x here is going to make that whole bracket go to 0. So negative 60 tells us that we actually are looking to get to the value 60 as a, sort of that point that was 0. So we're actually going to be going to the right, a distance of equivalent to 60 degrees. And then, of course, the last part is our vertical, and it's quite simple. Our vertical shift, we're saying take whatever we had before, whatever all this works out to be, and subtract 1 from it to establish our y value, or our f at x value. So if we take whatever was there and we shift it by 1, our vertical shift is move the whole graph down 1. Determine max and min. Okay, so again, thinking back to our original, we have the amplitude of 3. So what would have been our original graph up to that point, this is going all the way, this is a size of 3, this is a size of 3. And so in the original, with just an amplitude of 3, we would end up going up to 3 and down to negative 3. But of course, we're moving the whole grid down 1. So those two things together tell me that my maximum will be the 3 from the amplitude minus the 1 that I shifted down. My minimum value will be what would have been negative 3, 4. And then basically using those few things, I'm going to sketch the graph down below. Now, how you do this, I'm going to leave a little bit open-ended. I recognize that, I have all the information up top that I need, but sometimes sort of doing it in 2 steps might be a little bit nicer. So that's what I'll do here. If you can draw this in 1 step, that is fine, and you go ahead and do it. But, and certainly an easier question might be a little bit easier in 1 step, but when you have all 4 parts, you might find that 2 steps is the best way to go here. So what I'll tend to do is sort of graph up that point, so before the phase shift first, and then finish up with the phase shift. Okay, so what I know is my amplitude has to go up to 3, and then everything gets, and then I get 4 full cycles in 90 degrees. And I probably shouldn't have done 4 full cycles because it'll be pretty tight, but let's see what we've got. So amplitude up to 3 means I've got to get up here, and 4 full cycles in this 90 degrees means that my graph has to go to its maximum, down through the 0, back up to its minimum, or down to its minimum, and back up to the next 0 in that range. So I'm going to have 1 cycle right here, 1 here, 1 here, 1 here, to get my 4 full cycles in the 360 degrees. My maximum, we said, was 2, so I'm going to be, I'll deal with the maximum minimum afterwards, of course, with when I shift the graph around. So just dealing with amplitude and period to start, I've got to find my midpoint here, and I'm going to go up to 3, down to -3 in that, in that 90 degree area. So up, down, wow. Let's try that again. Up, down, back up again. And then sketching these, in case you didn't catch it, was once I've established that this is my 0, this is my 90, and that's the size of the entire period, then halfway between those is where my 0 occurs. Halfway between those is where my maximum occurs. Halfway between those is where my minimum occurs. Okay, so we can always just kind of split it up. And as long as you're doing a good job with these, I'm never going to be too fussy. So same thing here. Oops, that wasn't very accurate. And so this will be my 0. Halfway between is my other 0. And I can just kind of continue this out to the 360 degrees and do a decent job with it, but I'm not going to be too fussy. Again, I have to go halfway up to here, and then down, up, and then down. Other than this last one, which, well, actually, I guess they all got a little higher. Just round these off fairly closely. You should have a bit of an advantage on me when you're doing this on paper. That's basically my original, or that's my graph up to the point where I have the phase shift and the amplitude done. And come back the opposite way, put my zeros in. One of the reasons I would suggest writing down or one of the reasons we do have you write down, I'm going to pull this up a bit so I can reach it a bit better, then I'll move back so we can see the rest of the graph. Okay, so okay. So one of the reasons we do kind of write these things out up here first is so that if the graph isn't great, we can still see that clearly we understood what was going on, and the only thing was we didn't quite do the great job of drawing it. So that's the first part. That's the amplitude and period done. As I said, if you can do this in one step, if you can sort of visualize that phase shift in your vertical shift, fantastic. I thought this might be a little bit easier. And so once I know what I've got here, I'm looking to now phase shift it by 60 degrees to the right, and of course vertical shift it down. Let's try to keep that on the screen. So essentially, if this was my 90 degrees right in here, and this is my 180, 60 degrees is 2/3 of the way kind of right about in there. which means that the 0, I'm going to switch to red here, the 0 that was here now ends up right there. And then sort of each subsequent 0 ends that much further over. So this 0 will shift to here, this 0 will shift, okay, hang on just a second. Okay, sorry, change of plans. Right in the fly. Once we have this point, we have our graph drawn, we have the period and the amplitude done. What we're going to do then is just recognize the adjustments that need to be made, and we're going to do it without actually redrawing the graph. We're going to adjust the axes and the grid instead. Okay, so what we were suggesting was that this blue point right here, where the 0 was, now has to become 60. So the idea that we could have moved it over to a position of 60. This was 90, so 60 was somewhere in and around here, is one possibility. But better, I think we're going to go ahead and say that this was 0, and now that's the value at 60 degrees. So essentially, we're going to add 60 to all of our x values to indicate where they would be now if we had physically moved the grid over. So this is now 60 higher is 240. Add 60 here is 420. Add 60 here is negative 120 and negative 300. If you had chosen to redraw this after the fact, once we know where the numbers are, it'd be a much easier thing to do. Same sort of thing now with the maximum minimums and the vertical shift overall. We recognize that all of our maximums should be at +2, all of our minimums should be at -4, and that occurs because this should now be one lower at +2. This would be 1, this would be 0, this would be -2, -3, -4, and we just cross that one off if we need to. We could put -5 obviously as well. Makes for a little bit messier graph, but when I see this now, if I did want to translate it, I recognize that my x-axis just goes in right through there. I start at the 60 degrees right around here and continue out by just sort of equal spacing my 4 periods outwards, 4 periods backwards, and I'll get the same sort of grid in the -300 to 420 range. So just literally shift it over that way. So I apologize. I changed my mind, as I said, partway through. 2 classes admittedly had me slightly thrown off there for a second. But hopefully that's going to make for a much nicer way to draw these out. So we will draw the amplitude and period correctly on an original grid, and then basically numerically just do the math to do the shift for the phase shift and the vertical. And as I said, if we really wanted to do a nice final graph, take a second sheet from this and just recognize I'm starting at the 60 and draw it out from the 60 in those appropriate periods. Draw it back from the 60 and everything will be nice. So that'll be that for today. Again, unless you run into a one where you have all 4 different parts, going straight to a final answer might be an option as well. But I think for the sake of avoiding the shifting, once the tougher graph is already drawn, this might be the nicest way to go about it. So I'll stop there, and good luck. We'll see how this goes and ask lots of questions if you need to.